Problem 16 is a calorimeter problem. Unlike the previous calorimeter problem, though, it's one that actually undergoes a reaction as opposed to just like finding the specific heat of something. When we're doing a calorimeter problems, remember it's best to divide the world up into system and surroundings. So let's do that. We got the system and we've got the surroundings. The surroundings, as you remember, are always water. And the system is, in this case, some reaction of this SiH4 stuff. So I'm just going to write SiH4, but realize that it is a reaction of it with something else. Now, I've drawn a beaker of water to kind of help me organize my thoughts here. You'll notice that in this reaction, the water went from 11.7 degrees to 47.7 degrees. The temperature of the water went up. So it sounds like the heat is leaving the reaction of the SiH4 and it's actually going into the water. Now what that means for us is that the Q of the water, the amount of heat that the water is absorbing, it is being absorbed, so the heat is coming into the water. It's definitely going to be a positive sign at the end. And the other thing that we know is that the heat is going to be leaving the reaction, so it's going to be negative. So whatever happens, the delta H of this reaction should come out negative. Now to calculate this, remember we always start on the water side, and we know that we can calculate Q with this equation if we know the specific heat of water, which we do, the mass of the water, and I'll let you look in the reaction and see if you can find out what the mass of the water was. Remember, this always needs to be in grams, and then the change in temperature of water. And remember, it's always final minus initial. Once you know the Q of the water and you have that value, then it's just simply a matter of it's the same value for Q of the reaction, and we know that for reactions we actually call Q delta H. So we should have the answer. Now remember that when you get done, you're not going to be able to plug it directly in because the answer is probably going to be in joules, so whatever your value will be is in joules, you're going to have to convert that to kilojoules. And the other thing is you're going to have to divide it by how many moles were actually used in the reaction because they want to know what the heat change would be in kilojoules per mole. In this case, it looks like 5 gram sample of SiH4 was used. So you can find out how many moles of SiH4 were used and use that for your mole value.